Hey, and welcome to. Oh my gosh. Okay. Oh man. Welcome to the learning. I don't even know what this is called. Basically, you're here because you want to learn programming, and welcome to the video where you will learn the concepts of programming. This video is meant for anyone, kids ages 7 or up, or adults that have never ever programmed before. Using a really cool web-based application called Scratch. I am going to teach you the concepts of programming, the logics behind it, just what you need to know before you dive into actual scripting. Scratch here. Let me just hide myself. Boom, gone. Scratch here is a great way to visually see the code, see what's happening, and learn how things, how you put things together to make something happen. And let's do this thing. So, just a quick overview of what I got here on my screen is we have a cat, which is one of our sprites. This is the main game scene right here. Or, you can make a presentation. But in this case, we're actually going to build a game while teaching you some of the fundamentals and concepts of programming. And in this game, we can also change the background by going down here. Let's just go with that sky. And we can add more characters, sprites, and so on, just, by going in there and clicking them. So it's basically a backdrop, aka background, and then sprites, also known as characters, also known as sprites. Okay? Then over here are the visual building blocks, pieces of codes that build the functioning part of this presentation or game. There's some really cool things you'll see that other kids have made with this platform, and then you can publish them and everyone can see the awesome stuff you have done. Just to recap, what is programming? This kind of show you the visualization of what programming really is. It's basically taking little pieces of code, little parts of elements here that do other things, that do their own thing separately, and when combined, you make something happen. And that's what coding is all about. It's like Lego, right? Each individual pieces of Lego does its own individual thing, but when you put it all together, you have created something new. Okay? Now, programming, you need to be able to talk to the code and have the code listen at some point. For example, our scene here is supposed to do something once we click the flag to say go, right? And in many languages, this could be your main function. Whatever happens when your application starts or your game starts, it triggers a function. So something that knows to go with when the game starts. In this case, we click this flag, and the correspondent event that goes off when you click this flag would be this right here. So it's round at the top. There's nothing else we can attach at the top, but we can attach stuff to it at the bottom. So this will fire off once we click the flag, and perhaps we can use this. What does this do by itself, standalone? It rotates whatever it's on. So notice if I click on the apple, we don't see anything. If I click back on the cat, we see them because these are on the cat. So it rotates 15 degrees to the right, whatever it's on, right? And just by double clicking it, I get a little preview of what it does. If I press the flag, nothing happens, right? Follow along so far? Perfect. But by tying it to the when I press the flag event, now when I press the flag, it happens when I press the flag. But then I got to keep pressing the flag for it to happen over and over again. Why? Because there's nothing that tells it to do it again and do it again and then do it again. There's nothing here that tells it to do it over and over. It simply says when we click the flag, do it. And that's exactly what it did. And that's where you come in as the developer with your creative thinking to make it do what you want to do, what you want it to do, using the tools at your disposal, using the pieces of codes that we have here. So when you think about it, you say, okay, well, I have something here that's forever, and I have something here that repeats. I can use either one of those. So just like you would think, let's put the rotation, rotate 15 degrees to the right inside my forever and connect it to that. So now when I click the flag, it just happens forever. And because the forever is a constant refresh every, I want to say every millisecond, but it's pretty fast. It's faster than your eyes really see. It creates more of a smooth movement, very smooth. Likewise, we can take that out and look for something else like this. You see? Which causes them to move to the right on the X coordinate. All right, so let's get into a little bit of the coordinate before we go any further. Starting at the top, we have your pieces going from blue to purple, orange, green, and so on and so on. They're color categorized, and you can see what each color really does. Blue is responsible for mainly everything motion, look, basically everything that is displayed on the screen. For example, this here, when you click it, the cat will say hello, or, switches his costume. And now we'll go over what that is in just a minute. So he switches his costume. See, the cat has two costumes, so two different sprites. Apple only has one. Okay. And some other visual stuff. Sound, play sounds, events, or events that listen. That's when the computer listens for a certain button press, a certain button click, for certain things to happen. Like if the sprite changes, you can sense for when a sprite change, when something is too loud. You see here when sprite is clicked, so when we click it, and so on and so on. Controls are when we can do our conditional stuff, where we have the computer now think for us, when we can say, hey, if it's raining, do something else. If it's not, do something else. If this character move all the way to the right and touches the edge, do something else with it. So you have your if statement, your if and else, your wait until something happened. And then these open areas here would be where you create your conditions, right? Using things like operators, right? So you can check if a value is the same and that, or you can check if something is more than this and that one. Then once you put them in there, you have a condition. So if the cat's current position is more than 50, do some, right? And you can go back to motion and find, okay, well, here's the X position of the cat. Here's the Y position of the cat. So I can say if, boom, if the Y position of the cat is more than 50, then I'll do something in there. Let's not forget about sensing, which sense for also mouse clicks. If something is touching a certain color, you can ask a question and get an answer. They go along with each other there. And maybe a key press or mouse down. You can get all the mouse position in here. timer, all that great stuff. And of course, variables is something else that we should discuss later on in another video. But basically, if you've heard of variables before, the same thing. You just kind of like create your own little conditional data that you would use to either keep score or check something else that you want to be checked. All right. So let's see how coding here comes together really nicely. If I wanted the apple to fall from the sky, right? Notice that it's 2D, so it has the x value and a y. Midway in the x is 0, as it is in the y. What does that mean? Let me paint you a picture. You go up, y, 0. You go left or right, choop, choop. That is x, midpoint 0. As you go up, 1, 2, 3, it gets larger. As you go down, it's 1, 2, 3, but a -1, a -2, and a -3. Other people may say minus. Same for this. Up is a positive number, but down, you see it becomes a negative number. Okay, and they're like this. Y and x, both 0. You're in the smack in the center. And that's how it is with the coordinates. So going left or going right alone or left alone would only change this value. So if I make this 0, 0, and I went about 100 on the right, or negative 100, I'll go left. If I go up and down, it's both values are being changed, right? So to make it rain down, it's just negative on the y. So I would find negative on the y over here. I pointed here. Let's put that back to 0. To rain down is just negative on the y. So I'll go over here and say not the set y, but the change y. Remember, in programming, setting something to a certain value will simply make it move from the first value to the next value instantly. When you want to make it navigate, it's more like a change value, or the new value plus the old value. You can't just say the current value equals this. It will just blink from the top to the bottom. But by changing it by 10, it's like you're adding 10 to the value. So see how it goes up? Let's make this a negative value. So we're going to change it by a -10, which as I click it, it goes down. However, let's go ahead and say when I click the flag, I want it to always move down, right? So even if I drag it back up, moves down. I can stop it and drag back up, and it should stay. All right, let me crank this into gear, just go a little faster for you guys. I think you guys have caught that concept here, right? I'm going to take it out of the loop, and if I press the flag, see how it's all highlighted? That means it's constantly checking, running. But there's nothing in there to do, so nothing happens, right? Let's go to a random position, and I'll show you the difference between now set. Before using random position, I'm going to go ahead and use set. So if I move the apple, see, it just set. Set. And it's only on the y. So if I move the x, doesn't matter. It's bringing me back up there on the y. And height. So if I go this way, it just clicks back up to the top. Clicks back up to the top because it's always running. Always. Right? So the current position of it right now is 154 at the top. Right? So if I do a random position, let's just go into a random position. Right? If I just double click it here to show you what it does, random position. But with a combination of this, watch what happens. It stays at the top because it went to a random position, like maybe here, and then this part kicks in, which sends it back up there. So that's what we're going to do first, and then have it rain down, if that makes sense. So if I put it over here and click start, you see it went to a random position and then rain down. Click it again, 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 and laying it. It's just starting from a random position. So now, let's think about this. It's time to do some conditions, right? With the apple, if the apple reaches about this, let's see how far down it goes. All right, now we stop. It's currently at negative 96. It won't go any further down, right? So in my operator, I can get a less than, and I can also get one of these controls, my condition. So if statements are for my conditions, and the current position on the Y for the apple. So the Y position of the apple from the motion. So let's put these together. If the Y position of the apple is less than, we know it won't go any lower than negative 196. I apologize. It won't go any lower than 196. Negative 196. So I'm going to say if it's less than negative 195, put it in there. So as soon as it's like just like right here and about to go down to the last point, it will just hop back up to the top. At least that's what I want it to do. And we know what codes make it hop right up to the top. This spawns right up at the top, right? So I will right click on it and duplicate it, which gave me another one, and just put this back together. Now I'll put this inside of my to do when the condition is true. So this is a if statement, a condition where we have the computer think when the apple is low enough, boom, at negative 195 and about to hit 196, boom, once it hits 196, it becomes less than 195. I know 195 and 196 it seems more than 195, but this is on the negative scale, so it will be less than. As you go lower, the number increase, right? So if the position of the apple is less than 195, which puts it at 196, the very lowest it can go, the apple will then respawn at a random position at the top and then carry on with doing this part, which is what makes it fall down. This cannot be anywhere else except inside the forever loop. Not like here or nowhere else. We'll just put it right here. Now without this, it won't move down. So this do need to be like right here, forever moving down. And while we're moving down, we're forever checking for this condition. So we're moving down. Are we there yet? No. We're moving down. Are we there yet? No. We're moving down. Are we there yet? Yes. Send it back up. We're moving down. Are we there yet? No. We're moving down. Are we there yet? Yes. Send it back up. Are we moving down? You just get the point, right? So let's click and see what happens. And that is exactly what we're hoping for. So this part of the code happened one time. It goes to a random position just as we start the game. So boom, we start the game, it hopped to a random position, and then this forever take care of the rest. It constantly started moving down, and it's constantly checking to see how low it is. We'll send it back up, and it'll constantly start moving down again. So now it starts to rain. By increasing the negative 10 to maybe a negative 15, I'm sorry, that's a positive number, negative 15, it goes faster. Negative 20, even faster. Because all that's doing is how quickly it went from 0 to 20 to the next 20 to the next 20 to the next 20. So if we want to go slower, put it like at 5 or even at 1. Right? I'm going to go back to 15. And there you have it, guys. Now, I want you to follow me on the cat. This was the apple, and this is the cat. Let's make the cat follow the mouse. Really, really simple. It's about 3 blocks of code to make this happen. As soon as we click the flag, that is the first one, right? We click the flag, and we know that the mouse pointer motion, there's a go to. What's it go to? It could go to a random position, or it could go to the mouse pointer. That's fine. So we click the flag, it went to the mouse pointer, which is fine. But after that, it stopped following it. So if only it could follow the mouse pointer always. Well, guess what? It could forever. So that makes sense. I think that's it, and we're done. Look at that. That's all we needed. And do excuse me, I'm a little stuffy. I apologize. And there you have it, cats following the mouse. How about the cat eat the apple? That'll be nice. I'm going to make the apple fall a little bit faster. I think you guys know how to do that by now. So let's go back to the cat. I went over to the apple and made it faster. Now I'm heading back to the cat. Now, if we want the apple or the cat to eat the apple, we'll need to detect when the cat is touching the apple or when the apple is touching the cat. I like to keep the cat code simple, which is just movement. So we might just have the apple detecting when we touch the cat. Here's something I do want you to know, is that you can have multiple of these. We don't always have to keep our code all cluttered under one. So we're going to have another one that says when the flag clicks, and they both will trigger at the same time. And we want to forever. Boom. See how they're both highlighted? They're both triggering at the same time. The purpose that we want the forever in this case is that we want to always be checking for if the apple is touching the cat. We don't only want to do it when we click the flag. That would only happen when you click the flag. After you're done, it's done. But you need to always check. All right, so in sensing, there was a touching, and in touching, perfect. The cat is called sprite 1, as you can see right down here. So we can check for when something is touching sprite 1. We can check if the apple is touching sprite 1. So, where's that if? Here it is. So if the apple is touching sprite 1, we put it in the forever. So it's always checking if that happens. And when that happens, what are we going to do? Same thing we did before, right here. Send it back to the top. So a random position and send it back up to the top, right? Let's try that and see how it looks for now. Just the visual part of it. Because it should look as if the cat ate it. And it looks pretty good. It looks like the cat's eating it because as soon as it touches him, it disappears, right? It doesn't fall through him anymore. It's perfect. Why don't you slow down your apple from falling? Maybe a little bit slower. I'm going to slow mine down as well. Maybe 10. Yum, 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 yum. So, as soon as the cat, or as soon as the apple touches the cat, is the same as soon as the cat touches the apple. It's the same. So we put it as, and we put this code on the apple. So the apple is detecting when the cat touches the apple. Now, when is the best time to play a sound? Like yum or something like that. When is the best time? Where in this code would we put something like play sound? If we go to sound, there's a play sound. Oh, there's a chomp. That's perfect. Where would be the best place to put that? If you said here or anywhere in this condition is correct, probably right here. Why? Because this is when the apple is touching the cat. So this is when we actually ate it. And that would be a perfect place to put that sound. Let me turn my volume up so we can hear it if it goes off. Hey guys, congratulations if you've made it this far. The final part now would be just to add some scores, okay? Super, super easy. We're not going to get too much into it, but we are going to touch variables just to add the score for right now, okay? So in variable, there is one here that's called my variable. And if you check the box, it shows up on the screen like that. However, you can create your own and give it a better name. So I'm going to click on the create a variable or make a variable, and I'm going to call mine score. See, and then it checks, if you check the box here, it shows up and it looks pretty nice, and it's already 0, right? So there's a couple of things you can do with your variable. From the bottom here, you see we can hide your variable. Just make sure you click it and change it to your variable if you want to use it. There's a show your variable. There's a change your variable by a certain amount, which means increase the value of it by 1. So then each time you increase it by 1, it goes up. If it's 2, it becomes 3. If it's 3, it becomes 4. And then there's a set, which means it doesn't matter what it was before, but when you set it to this number, that's what it's going to be currently. So we take these two out. I'm going to set my variable and increase or change my variable by 1. So I'm going to change my score by 1 and set my score to 0. Now, I need both of these. Can you tell me where you would put something like the set to 0? If you said right here, then you are wrong. So as soon as the cat touches the apple, you want to set the score to 0. And let's turn off the my variable one. I'm not sure why it's there. We don't need it there. There we go. So nothing is happening. But look what this does, right? It sets it to 0. So when we start the game, that is exactly when we want the score to be 0. Because imagine someone, make a couple of scores, like score 5s, and then they stop the game and start the game again. They're still going to have 5. It's not going to start over from 0 unless we tell it to. You got to remember, the computer won't just assume. It never assumes. You have to tell it to. So as soon as the game starts, we can put this on its own block if you want and just do something like this. So every time the game starts, every time we click the flag to start the game, our score should go back to 0. Now, to actually change and increase our score by 1, that's exactly the same time as we're playing the sound, because that's when we're eating the apple, right? Let's try it. And see, our score is going up. And when I stop the game, if I play again, I start from 0. Now finally, I believe my cat is a little too small, or a little too big. I like to make him a little smaller. And here in the size, consider this 100 about the percentage of how big he is. So he's 100%. We can make him 150%, even bigger. Or we can make him 80%, even smaller. I'm going to make my cat 50%. And now he's eating a giant apple. And well done, guys. Now, if you're a child, great job If your age is anywhere from 6, 7 to 15, great job. You're on your way. This code here that you did today was amazing. I would show your mom and say, "Hey, mom or dad, look what I did." Because this is great, dudes. This is great. Great. I mean, this is awesome, okay? And if you are an adult and you've never programmed before, and you were able to go through this video as well, great freaking job. It may look childish and simple, but it is the beginning and the foundation of all, and I mean all programming language out there. These are the concepts right here. Right here, what you're looking at is a for loop. It's a loop. And you're going to run into those later in the future. And then what you're looking at right here is a if statement. Every freaking language will have an if statement in there. Developers have to tell the computer how to think and how to handle certain unexpected conditions, how to handle if something happens out of the ordinary, or if something happens that is meant to happen occasionally in their code. They got to be able to handle it. For example, even a simple login screen where someone would log in and type in their username, there's a condition to check if they typed it in correctly, if they're using the right characters. Imagine the login name is an email address and they don't put the @ symbol. There's a condition that checks to make sure that the format of the words that they input is an email address format, right? There's also a condition to make sure that the page that they're logging into loads. There's many conditions in the back end when something loads or when something is finished loaded or something that waits until something is loaded. So these are all fundamentals right here of any programming language, and that's what you guys covered today. All right, and great job. Now, if you want to expand upon this, you can simply duplicate your apple a few times. And what I would recommend is changing their speed. So maybe one is at -20, one was at -10, and I'll put one at -15. And then you can see they just kind of rain from all over in different angle, right? Expand upon this and send me a screenshot, put it in the description below, or just leave a description, a comment in the description below. Let me know what you guys did. Again, I apologize. I sound like I'm talking in my nostril right now. I am so stuffy. But really, thank you guys for watching. Any feedbacks, law feedbacks would be greatly appreciated. You guys have a great day. Thank you. Hey, you should become a part of this positive and educational channel by hitting that subscribe button. Again, thank you for watching. Have a great day.